10 o'clock local time here in Germany. Good morning, good day. My name is Ramin Esmaili from Softing Industrial. I'm the head of marketing communication. I've got with me Andreas Röck, head of product management at location Nuremberg, and today's topic being OPC UA server aggregation for modern IoT solutions. Enough from my side. I'll hand over to Andy, and I wish you an interesting webinar. Over to you.
Hello and welcome from my side for today's webinar, OPC UA server aggregation for modern IoT solutions. The agenda for this webinar is first, why aggregating, then some information about cyber attacks made easy, the simple and secure solution for all these topics. Then I will show you a little bit the secure integration server, some typical scenarios, and I will say minimum half of the time I will show you also a live demo, how easy it is to set up this, I will say, simple and secure solutions, and finally a short conclusion. Starting with the topic, why aggregating? If you take a look to this picture, we have here a small number, I call it small number, roughly 7 OPC UA servers and 7 destinations with OPC UA clients, OPC UA clients and cloud solutions. And if you see this picture, when you will have a connection from each client to each server, it is a really complex solution, even if we have only a small number of clients. To install, to configure, to maintain this solution, it's a huge effort, it costs you a lot of time, and finally, especially under security aspects, it is really difficult to handle all these topics. I will say not only the username, passwords, also the certificate stuff and so on. This is really a complex and unsecure solution. From this point of view, we see also some information regarding cyber attacks. The University of Aachen did a test in the internet and they find 1,100, I will say, OPC UA servers available through the internet. Quite simple to find them. And 24% of them have no access restriction. So you can directly access to these UA servers, which some of them were located really in a production environment. And so for me, more critical topic is 92% were misconfigured. So this is, I will say, a really critical topic. That's why we say it is quite simple to avoid such kind of attacks by using maybe our solution. Because not the standard, the UA standard is the problem, it's the implementation which will be done by the customers or by the users. If you want to see more information about this study, when we will provide you the, I will say, presentation, you can go to this link and you can get more information about it. Also, we have here an initiative from our German Ministry for Economic Affairs. They create a discussion regarding platform Industry 4.0. They have created a paper, Secure Cross-Company Communication via OPC UA. What does it mean? We have here some service provider which want to get access to some machines, to their machines, which they sold to the customers. And they also recommend, strongly recommend, to have here an aggregation server, which is under control of the owner of this network. And he recommends the access from the service provider to the machines. He controls everything. He controls the data which can be shown by the service provider and so on. The system is under control of this owner of the network via an aggregation server. And coming now to our solution, to the Softing solution, you can see the same picture like we have on the first page. But in this picture, we use our secure integration server as an, I will say, aggregation server. All the underlying OPC UA servers are connecting to our secure integration server, and we control with this solution or with our software the access from the clients to more or less the underlying UA servers. The core part of this, I will say, middleware is it generates an interface abstraction up to the client. It works as an aggregation server. It can also work as a cloud gateway. We have an integrated MQTT, publisher subscriber. And what is main topic is also on the security point of view, it acts as a security supervisor. So this central middleware controls the complete access to the production environment, to the UA servers. So it's a simple and secure solution compared to the initial picture on which you see here, I will say, a really complex solution. So from this point of view, we prefer using middleware like our data feed secure integration server as a central point on which you control the access to your production environment. The data feed secure integration server includes, on the one hand, an UA client interface, which is able to connect to up to 100 OPC UA servers. We have in the middle an aggregation option and filter option, mapping and access control. To see most of these parts, I will explain a little bit later more. On the right side, UA server interface, which allows to connect the clients to these underlying servers. And we have, last but not least, also a small OPC UA firewall integrated. In the live demo, I will say some words about it. And if a customer or if you want to use also this solution as a cloud gateway, you can use our MQTT publisher subscriber implementation for connecting your underlying UA server on a secure way to the cloud. Coming to the most used functionality, it's OPC UA aggregation. What does it mean? In our case, we have underlying servers, up to 100 servers, which we can aggregate to multiple address spaces. So we can generate into our system up to 25 address spaces. Address spaces are the representation of the data on the UA server, how the data are represented, and we are able to concentrate it from the underlying UA servers and build up own address spaces which are flexible in the organization of the underlying servers. You can assign to an address space only in this case 2 servers. The address space 2, for example, gets the information from 4 servers, and the last in this example only from 1 server. So we are here really flexible. This aggregated address spaces, we are then able with this application to assign it to OPC endpoints. We are able to build up 25 OPC endpoints. We called it also virtual OPC servers. From outside, it looks like separate UA servers. And the aggregated address spaces can be flexible assigned to these endpoint users. Last but not least, on top, we have an address space filter option, which allows you, in this case, to filter the address spaces which were coming from the underlying servers through this aggregation. And what is one core functionality of our solution? We can dynamically add or remove address spaces from servers without a restart. So if you get a new server, you configure the server, the connection to the server, assign him to the address spaces, and then it will be automatically available for the clients. Nothing else is to do, no restart, nothing else. I will show it also in the live demo. Coming to another functionality, not only be able to aggregate the address spaces, we are also able to load address spaces according to the OPC companion specifications. And in addition, when you have load this companion standards, we are able to map the information from the underlying servers to this newly created companion specification topic and provide this information to the client. Also here we can later on filter it. It's the same like on the last page. But the main topic is we are also able to load companion specifications and have a mapping from the underlying server to this companion specifications. This was now a short, I will say, theory introduction. I will switch now to a live demo. So just 1 second. So I will log in into the system. It's a Windows-based application, our data feed secure integration server. It will be configured through a web interface. When you log in, you see some information, and our main part is now connectivity. On the connectivity, we have in this solution two options, MQTT. I will not do a demo about MQTT, but it's simple to configure. I will do today a demo about the different UA topics. First, we have our OPC UA client application on which I configure the connections to the underlying servers. I have here connection to a demo server, but for this demo, I will add a connection, in our case, to a B&R PLC, which includes an OPC UA server. Just 1 second, I will configure immediately the connection to the server. Yes, we have it in support. This is the endpoint information from the server. You can configure here also the security modes from UA if you want to use something. For the demo, I will not use anything. You can configure the authentication settings. We also support the certificate topic. And here we have the first, I will say, access limitations. If you want to have it, you can say maybe if you want to not allow write access to your controller, you can disable the write access. Just as an information for our demo, I will allow everything. And here we come to our address space aggregation functionality to have multiple address spaces. I can here add a new address space on which I assign this B&R address space to HMI, and also I can have it to the all connection. I can disable however I want to do it. If I need multiple address spaces, I can also add an additional one. I call it only now test, and I have an additional address space. This B&R PLC with its integrated UA server is now assigned to 3 address spaces. I can test the connection. You can see test successfully. I get also some information about the manufacturer of this UA server. And I will say save. Okay. That's quite simple, quite easy to configure a connection. Coming now to the other side, I have here my OPC UA server endpoints. I have 2 default endpoints, but for our demo, I will create a new one. I called it HMI, which is the endpoint which will be accessible from an HMI interface, for example. I can specify here all the information from the UA, for example, the protocol, TCP or HTTPS, host name, the port, and suffix. If I want to add a suffix, I can see here the complete endpoint URL. And here I can specify all the security topics which are provided by the UA standard. For our demo, I will use the easiest one, but please do not use in the production in the real world, anonymous and no security. And here we have on the endpoint side the option to limit also the access rights on this endpoint. So you can disable, for example, the write access to this endpoint. These are the basic settings for the endpoint. Coming now to some special options of the endpoint from softing side, for example, the IP access filter. Here you can specify IP addresses from clients on the one hand which are allowed to connect to this endpoint. So we have whitelist, but also we have here also blacklist. So you can say this IP addresses are not allowed or this IP addresses are allowed to connect to our server, which helps you to limit the access to your endpoint to dedicated IP addresses. Additional option is here our access protection, which is a prevention for denial of service attacks. At this option, you can specify after how many failed authentication attempts, for example, you disable for a dedicated number of seconds your endpoint, or you have an increase factor. So first time we have 10 seconds, second time we have 50 seconds, and so on. And you can specify here also some additional options. For example, you can disable your endpoint after an attack permanently, or also you can drop all the connection. So you shut down more or less your complete endpoint. These are different options, what we have here on our access protection side. For our demo, I will leave it open. I have configured now my endpoint, and I will save the endpoint. This is our HMI endpoint, for which I have currently no user configured. I add now for this endpoint the user anonymous. To allow to connect to this endpoint, I can specify here on anonymous the number of connections for this user, and I can select here my address space, which I want to provide through this endpoint. For our demo, I use this HMI endpoint, and if I want to limit also the access, I can also limit here the access. I press save. Now I made a copy of my endpoint information. Now I use a demo client for connecting to this endpoint. Okay, and now I see all my objects. I see my PNR server with all its data points. So it was quite simple to have here a first server integrated in the solution. But one server is not enough. Maybe we add here an additional server. I have here a Siemens S7-1500, which includes an OPC UA server. It's an already predefined configuration from my side. I will test it. I hope it's working. Yes. Save. Oh, I missed something. Sorry. I forgot. I want to add also this PLC in the HMI address space. Why? Because the HMI application should be also have access to this Siemens PLC. I add it here, press save, everything works. And when I go now back to my demo client, which helps me a little bit to show you all the information. When I go now to my objects, to rebrowse, I have now my Siemens PLC available. I can directly access now also to my Siemens information. For example, my room temperature. This room temperature of my room is currently at 20.8 degrees. So it's quite simple also to add additional, I will say, UA servers to your address space and showing and made them available on your client interface. If you can see, I have nothing changed on my server endpoint. I have only added the S7-1500 into the HMI address space, and then it was automatically available in the client. This is quite simple, quite easy. What we have in addition is also the possibility, the address space filter. You can enable it, and here you can also browse the address space, for example, from the Siemens PLC, and here you can select single data points, whatever you want, and can filter on a folder level, or if you prefer it on an item level, you can directly specify the access level of each item. So it's a quite flexible, simple address space solution, which helps you also to finally, strip down the access from the clients to your application. So this was more or less the standard way for aggregating, the live demo for aggregating UA servers. And if you prefer, you can add here multiple servers, up to 100 servers, and you are really flexible to assign them to different endpoints and users. Coming now to the second option is the address space mapping. We have here included a functionality which we called mapped companion address spaces. I have a demo mapped address space loaded, which I provide through the demo mapped, I will say, endpoint. I will show you now a little bit this one. Just 1 second. I need another client. 1 second. Yep, here I have my client. Only I hope it is working. Yes, here you see, I will say, an address space which was generated by myself, which has the access, for example, to the underlying UA demo server. And you can see here also the variables and so on. And I'm now flexible. I will delete this. Now flexible to change the naming or the ordering of this address space. For our demo, I make it quite easy, quite simple, and only do a change of the naming. This must be currently done via a node.xml file. Node.xml file is a standard way on OPC UA to describe the address space of an UA server. This is the description of my, I will say, demo mapped address space folder. And here, for example, when I change, for example, the string, let's say here, the browse name is test, for example, and here I called it demo. Then you see also the difference. Then I save it. I must upload now the new, I will say, change address space. I hope it's a correct file. Yes. Save. It's now uploaded. And when I go now back to my client, this was my client, I must do now a reload of my address space. And here we see now my variable name is now changed to demo. And when we can see here the browse name, it's also test. So with this, I will say currently on a file-based Node.xml file, you can generate your own address spaces based on some companion standards. Beginning with April, roughly April, we will provide also a new release in which you can also do all this generation of these variables and also the complete address spaces via the GUI of the secure integration server. Currently, the mapping functionality with your own created address space, with your own representation, must be done via this Node.xml file. You can edit the Node.xml file like I did it via standard Notepad++, but you can also edit it via the Xiome, for example. Siemens Xiome is also a mapping tool for it. That was all from my side from the live demo. I will switch back now to the presentation. Short summary benefit of our secure integration server. It manages on a central point all the connections, especially the security parameter. You can restrict the access to the endpoints on an IP address level base. We have this denial of service prevention in our solution, which helps you to not be attacked. So from this point of view, you have this denial of service prevention. We have the encryption for the MQTT connections. We have bidirectional MQTT connections. And what is the core functionality of the secure integration server is the flexible OPC UA namespace aggregation, address space mapping, and the address space filter. This is the ideal solution for setting up, I will say, an OPC UA solution and secure solution. From this point of view, in the conclusion, I prefer on your side, you should try our secure integration server. You can download the secure integration server. It is a free trial version. It runs in the demo mode 72 hours. After the 72 hours, only a restart is necessary. And if you have any further questions, please contact us. Now I'm open for your questions. Please feel free now to ask some questions about the product, and I will answer it now.
Seems like you've been pretty clear on what you had to say.
It seems no questions from your side.
No, doesn't seem to be
Is it the first question? Is it a Docker system from Mr. Heuss? No, it is a Windows-based solution, but we have also the Edge Aggregator, which is a Docker-based solution, which has the same functionality except currently the mapped address space functionality, but it is, I will say, the parallel product of the secure integration server. It is in the same way to configure it, but it's a Docker container solution. It can be also downloaded from Docker Hub or from the Microsoft Azure Store, and it runs also 72 hours. Does it run on a local PC or on a server or both? Both is possible. You can run it on a standard Windows PC, like I did it for the presentation, but you can also run it on a server. Does it support or plan to support drop-in secure device onboarding? No, it's not planned. How do you compare it with Node-RED? It's a similar product like Node-RED. Node-RED has a lot of additional functionality. What is our, I will say, most benefit is this security stuff, and in addition, also, I will say, the address space aggregation in the multiple address spaces. The Node-RED is not so, how we say, perfect in the UA world. This is what I mentioned in this case. This is more or less the difference in Node-RED. Question from Mr. Vogler. Is there high availability possible? I prefer to run both, to run two instances completely in parallel. From this point of view, still two running in parallel, not something like a redundancy with a cold standby or something like this. From Mr. Alciadet, and can you comment on pricing? Yes, there I can comment small pricing. We have a flexible license model. You can buy a license for 10 connections to UA servers, which costs roughly 500 euro. And you can buy a license for 100 connections to UA servers, which costs you roughly 3,000 euros. Question from Mr. Shakil. What are the aggregation point at SUSE configuration meaning? That if we can choose which should be root node in the server. The aggregation root node, it's always the name of the connection. So if you aggregate it, the root node, it's always more or less the connection name from the underlying servers. I will give it a try, maybe make a demo with codices virtual PC, talking to each other using your product. Yeah, it is working. We can connect also to the codices OPC UA server, just as an information. From Mr. Vogler question, does it run on Linux? No, it runs on the Windows, but for Linux, we prefer our Edge aggregator, which is a Docker-based solution which can run easily on Linux. We do not provide a dedicated Linux application because we must build it for the different Linux distributions. That's why we have this Docker-based solution. It's called Edge aggregator in this case. Flex have the Docker version included on their side? Question. I didn't understand this. Do Flex have the Docker version included on their side? I didn't know Flex. Sorry, I cannot answer this question, Mr. Eiberger. Some additional questions?
Does not seem like it.
Okay, then I will say many, many thanks for joining this webinar, and I hope to see you next year on a webinar.
Yeah, also thank you from my side from Munich. Have a good season's time and hope to see you in one of our next webinars in 2024. Thank you and goodbye.
Bye.